Okay, so now I'm going to take you through numerical examples of angles between 0 degrees and 360 degrees. So let's do just a few examples, and I'm thinking that through examples, that's when everything is going to make sense. So what you would be asked to do, it is to write the following, which is what we're going to be looking at as the function value of an acute angle. So it's like they say, write the following as function values of acute angle. So in other words, they mean you may be given, let us say, sine of 290 degrees, and they want you to just write it as an acute angle. So in short, you are having that angle which is bigger than 90. So we know that an acute angle, it has to be that angle which is between 0 and 90 degrees, which is in the first quadrant. So trust me when I say the only way I could easily work out these things and fully understand them, it's when I tell myself that any angle which is bigger than 90, I have to reduce it. You reduce it to what? To an acute angle, which is an angle between 0 and 90 degrees. How are you going to reduce it? We use reducing formulas. What are those? The reduction formulae that we did. So you can see this is not an equation because it doesn't have an equal sign. It is an expression. So you are just going to simplify. And what we know about simplify is that you rewrite this same thing in its simplest form. So that means the simplest form would be converting this bigger angle into a smaller angle, which is an acute angle. But most importantly, you need to be aware that this angle that you are given, it's a bigger angle which will fall in which quadrant. So we have that cast diagram thing. So 290 falls in this quadrant number 3. So in quadrant number 3, this is where you are having 180 plus. So now let's start to do the work. So to work it out, you can simply say, actually, I'm still having my sine, but I'm going to apply a reduction formula. You will therefore have to say 180 degrees when you plus it with what? Let's see. So I would just say 290 minus it by 180, I get 110. So that means, let's see. Wait, why is it like I'm lying to myself? I'm definitely lying to myself because 290 degrees does not fall in the second quadrant, but it falls in the fourth quadrant. For that reason, it means I can't use the reduction formula of 180 plus, but I might need to use the one which is 360 degrees minus an angle. I hope you just learned how easy it is to make a mistake. So just make sure not to make that similar mistake. Then you will therefore have to say 360 degrees when you minus it with something. So that means you'll say 360 minus that 290, you have 70. Which means 360 degrees minus 70 degrees, it is the one that gives you that 290 degrees. So now you have your reduction formula that you can easily apply. So that means you've got 360 minus that. So which quadrant? Fourth quadrant. In the fourth quadrant, is sign positive or negative? We know it is negative. That means we have negative sign of 70 degrees, and that is the end of it. I hope that makes sense. So if you want to prove that indeed what I've done is correct, just say sine 290 degrees equals to, it gives negative 0.9396, then again say negative sine 70. Check if it gives you the same answer. Go up. Yes, it does give you the same answer. That's how you confirm that you have done correct calculations. So let's do another example and see. With another example, let's say you are having tan 197 degrees. Okay, again you ask yourself a question. You say, in which quadrant does this fall? Definitely this one, it should be the third quadrant. Yes, it should be quadrant number 3. And then in quadrant number 3, that's where we are going to have 180 plus. So that means you will say tan of 180 plus an angle that will give you 197. So 197, if you say minus 180, the difference, then it tells you what you must be having there. It's like you're trying to figure out what will be a number whereby you will say 180 degrees plus that number, and it takes you back to that. So you haven't changed anything. Imagine you being given let's say Seko as my surname. Let's say it's Seko 40. So this thing, I can still rewrite it as Seko, but in brackets, instead of writing 40, I can just say 30 plus 10. 30 plus 10, it is still 40. So I did not change anything. I just manipulated it such that I'm using a reduction formula of 180 plus, 180 minus, 360 minus, so that I will reduce it. Remember, we have done the reduction formula. So it therefore means you will say in this quadrant number 3, is tan positive or negative? It is positive. Therefore, it means this thing is the same as tan 17 degrees. And that is the end of it. Someone might be wondering that why am I not using 90 plus, 90 minus, 270 plus, 270 minus. I will still explain that part maybe after doing this last example. You can still test it and say tan 197, then you say it's equals to, it gives you that as a decimal. Let me press AC and say tan 17 equals to, let me go up. You see, it gives you the same thing. So that means what you've done is correct. You've done it correctly. But otherwise, in case if it gives you the same number but negative sign, then you know you made a mistake with the signs, then you need to correct it. So let's have a look at, let's say we are given cos of 120 degrees. So cos of 120 degrees, again, we need to know in which quadrant does the 120, not 180, but 120 falls. This 120, it is an obtuse angle. Obtuse angle meaning it falls in the second quadrant. So we don't want that angle to be obtuse, reflex, or revolution. We always want it to be an acute angle which falls in the first quadrant. So we have to reduce it because it's more than 90. So how do we reduce it? Because we know it's an obtuse angle, instead of us saying 90 plus, we will just use 180 degrees minus, let's see, 120 minus 180, the difference is 6. So that means it is 60 that I want to put there, where I'm going to say 180 degrees minus 60, it is definitely that 120. So now you are back to saying 180 minus, it's in the second quadrant, is cos positive or negative? It is negative. Therefore, this thing is the same as negative cos of 60 degrees. Then you are done. So if you punch cos 120 degrees equals to, and you punch negative cos 60 degrees, you will get exactly the same answer. So now let's see what happens if you were to use the 270 plus, 270 minus, 90 plus, 90 minus. and then we will make a conclusion based on that. So again, that same example, let's say you had sine of 290 degrees. Which quadrant? Again, it falls in the fourth quadrant. So if you decide to say this thing, it is the same as 270 degrees plus what is it? Plus 20. Yes, plus 20 degrees. It is the same as that 290. But the challenge with you using that 270 is because when it is 270, you need to remember that this thing changes. So you will see this falls in the fourth quadrant. In the fourth quadrant, this thing is negative, and because it is 270, it must change. It changes to what? It changes to cos. Then it becomes cos of 20 degrees. So that's why I avoid using the 270, because I still need to remember that when it is 270, it changes. So that means even if you punch negative that cos 20 degrees and it says equals to, it still gives you that same answer when you punch sine 90 degrees, of which you see now here you used that one of 360 and you got negative sine 70. But when you use the one for 270, you get a different answer, but not necessarily a different answer, but a different trig ratio as your final answer, but the value is still the same. So maybe let's do another one using that. What can we do there? I think okay, we are now going to jump onto this one of B. So this one of B, where we were given tan 197 degrees. Okay, again you will see this thing is the same as tan of. In which quadrant does this fall? It falls in quadrant number 3. So in quadrant number 3, you can still say 270 degrees minus, what will that be? So you say 270 minus that same angle, 197, gives you 73. So that means it's 270 degrees minus 73. Then from there, you just need to remember that if it is tan that you are given, it changes to cot. So you will say, okay, this thing, it falls in which quadrant? It falls in quadrant 3, and in quadrant 3, tan is positive, but because it's 270, then that tan has to change to cot. Then it becomes cot of 73 degrees. So if you want to punch it on a calculator, remember cot is the same as 1 over tan 73. So that means if you want to prove it, that's what you want to punch on a calculator. You will say 1 over tan 73 degrees. Let's see what the answer is. It gives you 0.3057 as a positive answer. And then what happens when we say tan 197? Let's see. Yes, it gives exactly the same answer. Then you know you've done it correctly. So let's look at this one of C, where we had cos 120 degrees, where we will say in which quadrant? Second quadrant. And in the second quadrant, that's when you have cos of 90 degrees plus, is it going to be 30? Yes, it's going to be 30. So can you see my first step? I'm not changing anything, honorable member. I'm just rewriting it exactly as it is. Like you're having cos of 5 and cos of 5 is the same as cos in brackets 2 plus 3. You haven't changed anything. You are just manipulating it so that you will somehow reduce it. So you can see that my final answers, I'm having angles which are now acute angles. All of them must be acute angles. That's what the reduction formula I used for, to reduce a bigger angle into a smaller one being an acute angle. So now 90 plus, you're going to say 90 plus in the second quadrant. In the second quadrant is this thing positive or negative. In the second quadrant, it's sign cos is cast. So that means in the second quadrant, cos is negative. Then you will say negative, but remember to change it to sine so that it is sine 30 degrees. So why does it change? Because it's 90 degrees. So you can see I've done it in two ways, where the other one was changing, the other one is not changing. So now let's make a conclusive statement so that you will always know how to reduce it to avoid making mistakes. So maybe let me use different colors there to say on that cast diagram we have this vertical line, if you remember, and for this vertical line, that's where we have the 90 degrees and the 270 degrees, where you can say plus or minus. You remember 180, 90 plus or 90 minus. So maybe let me do this and say okay, let me just add another horizontal line there, that one which is for 180 degrees and for 360 degrees, whereby this one for the horizontal line for the x-axis, they do not change the trigonometric ratios, they remain as they are, easy to work with. But these ones you can easily forget, they have to change. So maybe to conclude, we can therefore say when you are having a reduction formula of 90 degrees, it could be plus or minus whatever angle, and also when you have that one of 270 degrees, it could be plus or minus depending on the quadrant in which it will fall. These ones, they are going to change. What are the things that are changing? It is the trigonometric ratios. So that means sine will change to cos. Even if you are given cos, it will change to sine. You can just remember that. As a bonus, I can still say same as tan, it will change to cot. For some reason, if they try to be tricky and they give you cot, it changes to tan. And then this one, it doesn't change. So I'm pretty much sure that now you have a better understanding. So the one for 180 degrees, whether it's plus or minus, and also this one of 360 degrees, whether it's a plus or a minus, whatever angle, you have seen that the reduction formula, they don't change. So what am I going to write there? Not changing. They are not changing. So that means if you are given a cos, it remains as cos. You just need to be careful of the signs. Even if it is sine, it just remains as that. So I'm pretty much sure that you now have a better understanding of what is going on and how you deal decisively with this type of problem. So that's how you can easily work it out, where you have the 90 plus or minus 27. So obviously the 90 minus, it is the one that will fall in the first quadrant, even though you may not use this one. You know why? Because already it's an acute angle. So that means you will be expecting to be given an angle which is bigger than 90 and you have to reduce it. That's why in my examples I'm just not having one where I will say 90 minus, because it's already reduced, if you get my point. I think I might leave it here because I think I've covered all that I wanted to cover for today. So on the next lesson, we will therefore look at the angles where it is a negative angle, and I will therefore teach you how you deal decisively with those. But just so that I don't give you too much information in one lesson, I will just limit it to this one, and then you can now start preparing to write your short test and see how you will perform on this one. Until we meet again.